All right, so we're going to do the last couple of problems from section 5.1. The first one here, find the area bounded by the parabolas x equals 8 minus y squared and x equals y squared. So what we want to recognize back from the pre-calculus days is that these are two sideways parabolas. And one thing that's going to be important is knowing what they look like so that we can make a decision on how to orient our integral. So we do need to find the intersection points, and so I'm going to take the two x's and set them equal to each other. That's going to give me 8 equals 2y squared. I get y squared equals 4, and so that of course is going to give me y equaling plus or minus 2. So we do get two y values there. So y equals plus or minus 2. So that's, you know, up here and down here. But we need to know what x values. So when y is 2, so let's see. So when y is 2, if we put in 2, we're going to get 4. And if we put in negative 2 for y, we are also going to get 4. So they intersect at 4, 2 and 4, negative 2. Now you can kind of think about this, x equals y squared just means that you can take every y value squared and that'll be your x value. And of course we're talking about every x value being positive, so this is a parabola heading in the positive direction. So it's literally just like y equals x squared, but just sideways. And then the other one, x minus y squared, well, the minus y squared is sending us in the opposite direction, so that's going to be in the negative direction, so it's going to open up to the left. And you can see that if y is 0, x is 8. So we get this point, and then we also know again that it has to meet up with the other values that we have. So you could put in, if you put in, you don't really need to do any more than that, I don't know. But if you put in y equals 1, you can see that you'll get x equals 7, so you could do, something like this just to create, the best picture possible. So it's going to come down. That's not great. I missed that point, but I think you get it. So we're trying to find the area that's in here. And so it's probably pretty obvious, hopefully to you right now, that we're going to have to do this in terms of y, that we're going to be looking at the idea of rectangles that look like this, okay, and that the height of each rectangle is going to be the difference between here and here, which is the difference between two x values, and so we have to write this in terms of y. So luckily, our 8 minus y squared is always in front of the x equals y squared. So because of that, we do only need one integral, which is nice. We want to remember that we're integrating from down here, so note that this is 4, negative 2, and up here is 4, 2. So we're integrating down to up, so that will be negative 2 to 2. So now all we need to remember is that this function is the x equals 8 minus y squared, and over here is our parabola x equals y squared. And so because of that, we know that we are integrating from right to left. So our function that's on the right is first, because that function minus y squared is going to give us that length of the slice. And then we're just integrating that with respect to y. So it's fairly straightforward at this point. We are going to have, I'll do one more line over here, just simplify this a little bit. We can see that we'll have 8 minus 2y squared, that's dy. And so when we integrate, we'll have 8y minus, adding 1 to the y squared, we'll have y cubed, and then 2/3, and we're going from -2 to 2. So when we plug in, because now we have two values, you might be able to see their symmetry here. There is an aspect of the fact that this is even. So if you understand that, you could actually do this a slightly different way, but slightly easier. So when we plug in 2, we'll have 16. And then when we put 2 into the other piece, we will have 16/3. And then from that, we're subtracting what happens when we put in -2, which will be a -16. And then what happens when we put a -2 into the second piece, and that's going to give us a positive 16/3. So when this gets evaluated, you'll see we end up with 16 plus 16, which is 32. And then we're subtracting 16/3 and another 16/3. So 32/3 is getting subtracted. And what that actually leaves you with is, not surprisingly, 64/3, which is about 21 and like a third units squared. Actually, that's exact if I don't put a decimal there. And so that is the area between those two curves, doing that with respect to y. All right, for the last one, find the area bounded by the curves y equals sine x and y equals cosine 2x. So in this one, we don't have the picture. We are told that we have some bounding of just vertical lines, x equals 0 and x equals pi. And so that is, this line here and this line here. So the area that we're doing is going to be between that. So that's good to know. And of course we do need the intersection points. So right now we see that we have sine x and cosine 2x. So we're thinking we're probably going to be doing, our rectangles in the normal way, but we'll see what it looks like. So we do need to find intersection points. So I'll do sine x equaling cosine 2x. And this is where that pre-calculus knowledge comes in. So you want to rewrite your cosine of 2x with an identity. And this comes up every once in a while in calculus, but one of the identities for cosine 2x is 1 minus 2 sine squared x. And now you're solving a trig equation. So this should just be kind of information that you have from your pre-calc, but it's very common, specifically trig, to have something like this. I'm not a huge fan of the negative, so when I set this equal to 0, because I'm bringing everything to one side, I'm actually going to change the signs of everything. I'm going to multiply through by a negative. The reason I do that is I just don't want my leading term to be negative. But now what you have is a trinomial. And so what we're going to do is we have 2 sine x, sine x. So notice I have a sine x squared, and then I've got a sine x, and then I've got a constant. So factoring is pretty common. We want to have a positive middle term, so I'm going to have a positive here and a minus here. So just make sure that you understand that from back in the day. And so we'll have 2 sine x minus 1 equals 0, and sine x equals -1. So remember, we're only between 0 and pi. So for sine x being -1, if we think about that, that is x being 3 pi over 2, but that is not in our interval. So there's more intersection points, but they're not part of it. And over here we'll have sine x equals 1/2, so we're going to add 1 and divide by 2. And so on the interval from 0 to pi, because that's where what we're sticking with there, we're going to have pi over 6 and 5 pi over 6. So so you can see that the intersection points are going to be pi over 6 1/2 and 5 pi over 6 1/2. So pi over 6 1/2, 5 pi over 6 1/2. So up here. And then what you can do is you can graph sine x. So you know that sine x starts at 0, and that at pi over 2, sine x comes up. Sine of pi over 2 is 1. And then that sine goes back down at pi. You know, we have 0. So this is going to come up, and it's going to come down, and you have something that looks more or less like this. For cosine of 2x, you can probably just, easiest thing would be to put in some values. So at 0, you still have cosine of 0, which is 1. At pi over 2, when you put pi over 2 in, you're going to have cosine of 2 times pi over 2, which is cosine of pi, which cosine of pi is -1. So that's going to head all the way down to here. Okay. And then you are going to have cosine of pi is technically cosine of 2 pi for cosine 2x, and that will bring you up back to 1 here. So, and you have to think about those intersection points. If you want to do a better picture, you can think about pi over 4, because cosine of pi over 4, well, if you have cosine 2x, then cosine of 2 times pi over 4 is cosine of pi over 2, which is 0. So you're going to have a 0 here, and you're also going to have a 0 at 3 pi over 4, so something like this. So now just to kind of like connect these so we see what this looks like, it's going to do this, then it's actually going to do more like this, and it's going to come up, and then it's going to do this. Whew, okay. Point being here, we see what we need to integrate. So you actually have this piece here, you have this piece here, and you have this piece here. And so we have 3 pieces. And there is some symmetry in these pieces, so you can see that you'll have some pieces that are the same. You can see the symmetry in the first piece and the last piece. So if you can recognize that there is that symmetry there, you could actually do 2 integrals. So what I'll do here is we'll think about the fact that we do have different pieces above at different times. So do notice that. So from 0 to pi over 6, I want you to see that the cosine of 2x is above. So we'll have cosine 2x minus sine x dx. But I want you to see that the last piece is going to be the same size. I know it doesn't look perfect, but think about the fact that these are all, you know, periodic and stuff. So we could just do this, and that will give us this area of this piece and the area of this piece. And then we're going to add to that what we get when we do from pi over 6 to 5 pi over 6. And that's going to be, now in that case, you have your sine function above, and you have your cosine of 2x below. So all of those rectangles are going to be having that height. Okay, like that. And then it just comes down to integrating and evaluating. So hopefully I have enough space here to kind of make this happen. We'll decide how much I can show. But the integrals are, you know, essentially the same. So you'll have the antiderivative of cosine, which is sine. So you're going to have sine 2x, but understand that the derivative of this is cosine 2x times 2. So we need to make sure that when that happens, because we don't have anything in front of our cosine 2x, that we put in the 1 over a, or 1 over 2. So this is from substitution. And then the antiderivative of sine is going to be a negative cosine, but we have that negative there. So we'll have plus cosine x, and then we're evaluating this from 0 to pi over 6. Okay. Then we have our second integral, and that's just going to be the antiderivative of sine. So you're going to have negative cosine of x, And then the antiderivative of cosine is sine, but you have that negative there, so you're still going to have that negative. And then the 1/2 sine of 2x. And then that's going to be evaluated from pi over 6 to 5 pi over 6. Okay. And then it's just plugging everything in and seeing what you get. So, you know, you have to be sharp with your skills of trig, but that's it. So let's see. So we're going to have 1/2, and then we're going to have sine of 2 times pi over 6. So that is sine of pi over 3. Sine of pi over 3 is root 3 over 2. And, okay. And then add to that what happens when you put in cosine pi over 6. Cosine pi over 6 is root 3 over 2. All right, but then you have to subtract what you get when you put in 0. So you're going to have sine of 0, which is 0 times 1/2, so that's fine. And then cosine of 0 is 1. All right, so we have that first piece. And then over here, you're going to have a negative and then cosine of 5 pi over 6. Cosine of 5 pi over 6 is going to be a negative root 3 over 2. And then we're going to have, let's see, what happens when we put in sine of 5 pi over 6, which multiplied by 2, so 5 sine of 10 pi over 6, which is sine of 5 pi over 3. So 5 pi over 3 is going to put me into the fourth quadrant, and so that should be a positive 1/2. So we should have a 1/2 times another 1/2. No, that would be a negative 1/2 if I'm in the fourth quadrant for sine. Okay, so I'd have that, and then minus what happens when we put in pi over 6. So we've got negative cosine pi over 6. That's going to be a negative root 3 over 2 minus, and then we have sine of, this will be pi over 3 when we do 2 times pi over 6. So sine of pi over 3 is root 3 over 2, and then that gets multiplied by a 1/2, so root 3 over 4. Okay. Ooh, hoping that that's it. If we do all this, we should get 3 root 3 over 2, just combining it all together, which is about 3.196 units squared. So notice this is pretty, you know, zoomed in here because this whole thing is just 1, and then we have a little piece on the bottom too. So that is what the answer should be. You can check that, make sure I'm right. But that should be all the values that we need and everything that we want. So good luck with that. And that's the end of section 5.1.